So here we have a condition that A, B, and C adds up to pi radians. We need to prove the following. So here what we'll do, we'll start the proof from the left hand side. So let's rewrite the expression on the left hand side. So we have sine of angle A divided by cosine of angle B times cosine of angle C, added to sine of angle B divided by cosine of angle C multiplied to cosine of angle A. And finally, we have the third term, sine of angle C. So that's divided by cosine of angle A times cosine of angle B. Now what we'll do, we're going to do some manipulation here. So for the first term, what we'll do, we're going to multiply both numerator and the denominator with cosine A, such that we get sine of angle A times cosine of angle A. So we have to do that to the numerator as well. So we get a denominator as well. So we have cosine of A times cosine of B times cosine of C, added to. Now coming to the second term, we are going to multiply the numerator and the denominator with cosine B, such that we get sine B multiplied to cosine B in the numerator, and then in the denominator we are going to get cosine of angle A times cosine of angle B times cosine of angle C. This is going to get added to the third term. Again, we are going to multiply the numerator and the denominator with cosine of angle C, such that the denominator becomes cosine of angle A times cosine of angle B times cosine of angle C. Now here, the reason why we multiplied and divided with a cosine function for each of the three terms, because in the numerator what we have is something of the form sine theta multiplied to cosine theta. Now if we multiply with a factor 2, then this is simply sine of 2 theta. So that means the numerator of the first term, that becomes sine, what we here, we need a factor 2 also, that's missing here. So what we'll do, we're going to multiply and divide by 2 for in each of the three terms. So we're multiplying and dividing by 2, such that the first term in the numerator becomes sine of angle 2A. That is going to get divided by 2 times cosine of angle A times cosine of angle B times cosine of angle C. In fact, what we can do, we can combine these three terms because all of them have got the same denominator. So we only have to worry about the numerator. So the second term in the numerator becomes sine of angle 2B, plus the third term in the numerator becomes sine of angle 2C. Fine. Now we have a standard formula for sine of 2A plus sine of 2B plus sine of 2C. That's a standard trig identity. So let's note it down. We know that sine of 2A plus sine of 2B plus sine of 2C. This is equals to 4 times sine of angle A times sine of angle B times sine of angle C. So we will be using this to replace our entire numerator with 4 times sine of angle A times sine of angle B times sine of angle C. Well, straight away using the result, we have already showed why this is the case. So in the denominator, we have 2 times cosine of angle A times cosine of angle B times cosine of angle C. So 2 times 2, that's 4. Now we have 2 multiplied to, so sine A over cosine A, that becomes tangent of A. Multiplied to sine B over cosine B, that's tangent of B. And then we have sine C over cosine C, giving us tangent of C. And we see that's exactly the expression on the right hand side. So that equals the right hand side. So therefore, we can say that we have successfully showed that the left hand side equals to the right hand side. Hence proof.